Kamiak Butte Term Report 7 by Ben Murphy. Geologic foundations of Kamiak Butte. Flood basalts. The area around Kamiak Butte has been shaped over the years by a series of geologic events. This includes massive glacial and volcanic flooding events. Starting around 17 million years ago, the hotspot volcano, now known as Yellowstone, was in a different place in its geologic path. It was located around where southwestern Idaho is now. Eastern Washington was flooded with basaltic lava flows from this location. Through fissures fed by feeder dikes, the lava flows lasted around 17 million years ago to around 6 million years ago. The basaltic lava flow nearly engulfed all the belt supergroup of rocks, except for Kamiak Butte and a few other tall peaks. The lava floods covered an area of around 63,200 square miles of the Pacific Northwest. Glacial floods. Around 15,000 years ago, a large series of glacial floods occurred. These floods are now called the Missoula floods because they originated in Glacial Lake Missoula, where Missoula, Montana is now. The lake was up to 1,000 feet deep in some places, and evidence of the shorelines is still visible in Missoula, high above the city. The glacier bursts in periods of around 55 years, from around 15,000 years ago to around 13,000 years ago. The water rushed over the landscape through Idaho and Washington, down through the Columbia River Basin. This huge recurring flow of water changed the landscape massively and swept away a lot of soil and left a relatively barren landscape behind. The water came through the Pacific Northwest at speeds of up to 80 miles per hour. The largest source of water flooding was the Missoula floods because it was multiple floods. But there was another flood that originated in Glacial Lake Bonneville. This was a flood of water that only occurred once and traveled all the way north, up through Idaho and Washington, and through the Palouse. This flood ran through the Snake River and eventually made it to converge with the Columbia River. This individual flood was much larger volume of water in comparison to an individual flood from the Glacial Lake Missoula. The Palouse region was much more fortunate than other regions in Washington, as it was where most of the low soils were carried by the wind, creating a fertile landscape that makes the Palouse such a good location for agriculture. Climate interactions that contribute to Kamiak Butte. Air masses. Air masses are large bodies of air that have generally similar temperature and moisture properties. The Palouse region is fed by a marine polar air mass. Marine polar air masses are moist and stay cool as they originate from the poles and, in our area, travel south over the northern Pacific Ocean toward the North American continent. This mass is heavily affected by the Cascade Mountains to the west of Kamiak Butte. Macroclimate. Kamiak Butte lies within the Palouse region in a marine-modified continental climate. This type of climate would generally be more extreme compared to how it is now. Since it is modified by the marine climate, it becomes slightly more temperate than it would if it were further from the ocean. The effect of the oceanic climate is not as effective as in the Palouse region due to the large climatic barrier to the west. Continentality. Continentality deals with the measure of the difference between ocean and continental climates. Specifically, it is characterized by the increased range of temperatures that can be found over the land as opposed to over the oceans. The effect in eastern Washington is especially apparent due to the exaggerated effect that the Cascade Mountains give continentality. Eastern Washington is significantly less affected by the ocean climate due to these factors. Continentality because we are far away from the ocean, and the rain shadow effect created by the Cascade Mountains. Topography. The Palouse region is a region that generally is not hugely diverse in elevation. It has gently rolling hills mainly, but a range of elevations in Palouse is generally on the low end of ranges in terms of average elevation differences. This is why Kamiak Butte is so prominent here, because of how little difference there is elsewhere in the region. Kamiak Butte is about 1,000 feet higher in elevation than the surrounding area. The Palouse is also heavily affected in terms of climate by the Cascade Mountains to the west. Rain shadow. Mountains create an area of low precipitation on the leeward side of mountains, where the air passing over had already lost most of its moisture through precipitation on the other side. This is evident in the difference between western and eastern Washington, where air moves from the southwest toward the northeast over the mountains, where there is a rain shadow effect on the other side. Kamiak Butte is affected by all these factors: rain shadow, continentality, topography, and air masses. The area is marine modified continental type. Because of the Cascades and the rain shadow that they create, we have a drier climate protected from the oceanic climate west of the Cascade Mountains. Kamiak Butte biome. The North American Western Interior Shrublands. Kamiak Butte is a unique feature within the Palouse. It stands out amongst the rolling hills that contain acres of ample agricultural land used for wheat, alfalfa, lentils, and other crops. It is composed of the remnants of an ancient mountain range covered by the Columbia flood basalts about 17 to 14 million years ago. Much of the Columbia Basin is dominated by shrubland, which means minimal wooded areas. Originally, the Palouse region's native plants were composed of extensive shrubland. This environment is especially apparent on the south aspect of Kamiak Butte, where there is no agricultural activity and shows a more natural Palouse setting. Woodlands biome. On the other side of the butte, there is quite a massive change in vegetation, climate, and weather. The vegetation change is due to the lower amount of solar radiation, since this side faces north, generally away from the sun's direct light. So species that do not thrive and survive in a higher solar radiation environment can live on the north side much easier. The solar radiation and higher wind levels of the south side cause it to be much less conducive to trees like the western larch and Douglas fir. These trees thrive in lower sunlight environments, hence the fact that there are so many more plant species on the north side. The only trees that can survive on the south side are the ponderosa pines. These trees are able to live on this side because they can live in a drier and sunnier environment than the Douglas fir and western larch. The ponderosa pines on the south aspect are still not living as easily as they are on the north, and they are much more sparsely populated on the south side. There is also a much larger and more diverse shrub environment on the north aspect. At the top of Kamiak Butte, these two environments converge and create a mix of both environments containing elements of both types of biomes. Kamiak Butte Field Report. The north aspect of Kamiak Butte has characteristics that differ greatly in comparison to the south aspect. These differences fall under the categories of climate, vegetation, and wildlife. The north aspect houses a much larger variety of plants and animals than the south aspect does. This is mainly due to topography and geographic location. Since we are in the northern hemisphere, the southern aspect of Kamiak Butte gets significantly more sun than the north aspect, because there is a significant difference in slope angle from one side to the other. In terms of topography, the south aspect faces toward the sun, so the north aspect gets direct sunlight blocked most of the year and gets very low angled light, which spreads out the radiation wider than direct sunlight. The south aspect of Kamiak Butte is so much different due to orientation toward the sun as well as higher wind exposure than the north aspect. The south aspect is always receiving more sunlight than the north aspect. This affects moisture availability in the soil. It also means that the plants that live on the north aspect that prefer shade and more moisture will not be able to thrive and survive on the south aspect. This face also receives more wind than the north aspect. This is because wind predominantly travels in the direction of northeast in this area of the world. This will negatively affect soil moisture retention as well as soil erosion. These harsher conditions make it more difficult for the wide array of plants and animals that live on the north side to live on the south side. Lower vegetation generally means lower animal distribution also. Student theme report. For my student theme report, I did it on wolf reintroduction. This would greatly benefit not only the Palouse area, but any other areas that wolves have been eradicated from. Wolves benefit many different parts of ecosystems. This has been evident in other areas where wolves have been reintroduced, such as Yellowstone National Park. Wolf predation helps control the populations of their prey, solving problems that arise with overgrown populations. Wolf reintroduction also changes the behavior of their prey, such as elk. Prey, such as elk, with wolves present, will be much less likely to go places where they can be easily hunted, creating areas in which plants can grow more freely, creating habitat for other animals. The Palouse region is a place that historically was habitat for wolves, meaning that reintroduction can greatly benefit the area.